So we're back and we're talking about chemistry in this mini episode of anatomical analogy. So, chemistry, boo, boo. I don't want to talk about chemistry. Well, guess what? We're gonna have some fun with it. Chemistry can be fun. Get that other stuff out of your mind. Chemistry's fun. Chemistry's fun. Chemistry's fun, and we're gonna have fun with it. So, chemistry is very important, obviously, within our bodies and just within life in general. So, thank chemistry for living. But there's four different types of chemical reactions. Let's first actually discuss what chemistry is. So it's how bonds are formed and how bonds are broken. Simple as that. So when bonds are formed, it requires energy. That's pretty common sense there. When bonds are broken down, it releases energy there. So this kind of ties into the anabolic catabolic reactions we discussed earlier, except we do give a little bit of a different name to them here. So there's four different types of chemical reactions with four different types. Four, not three, four, not two, four, nah, I'm not gonna do that. Not one, four. So there's synthesis reactions, decomposition, exchange, and then reversible. So we're gonna start with synthesis here. That's the building reaction. This is comparable to it's just another name really for anabolic reactions. So this is the building reactions. It requires energy. Think of the analogy we discussed a few episodes ago of the brick layers building a house. So brick by brick, you're building from a bunch of smaller fragments into one big house. It requires energy. Decomposition is the catabolic reaction. So this is the breaking down reactions. This is the releasing energy. So back to the demolition crew. Boom, they're coming in. They came in like a wrecking ball, just like Miley Cyrus did, except actually we're not. We're just not even gonna go down that path. But the demolition crew knocking down one house into a bunch of smaller pieces. That's decomposition. So since this building requires energy, decomposition is the catabolic reactions. Breaking down release energy. That's somewhat review for us here, just different names. There's also two more reactions, chemical reactions. Oh, what joy, I know. But exchange reactions, the combo of a synthesis and decomposition reaction. So what you do is take a molecule, you break it down, and then you recombine it into different forms here. So it's actually the decomposition first. So big molecule, break it down, recombine it into different forms. So an analogy for this is, so theoretically, let's say we have two houses we're deconstructing that are side by side. We deconstruct each of them brick by brick and component by component there. So take the door off, take the roof off, take not the wheels off the car, that has nothing to do with the house, but take maybe the garage door off. I don't know why you do that, but so you take all these two houses apart, then you have the bricks, you got the doors, you got the roof of each one. But in an exchange reaction, you would take the bricks from one house, combine it with the door and the roof from another house to build a house, and same exact thing with the other house. So you take the bricks from this house and use the roof and door to build another house there. So completely strip down two houses, use the bricks with the door and roof from another house, and same exact thing. So use the garage door, the front door, and the roof of this other house with house A with the bricks of house B to build another house there. So just strip it down and then build it back up differently. So it is that combination of decomposition, boom, breakdown, and then the synthesis or anabolic reactions, the building back up. And then last but certainly not least here is reversible reaction. So this is a reaction that can go in both directions. So it has pretty much two arrows to it. I'm not sure how we're gonna, I don't know how we're gonna do it here, but I'll actually draw it on the page here. So reversible, it can go forward or it can go reverse there. So that's what we're going to see when we see a reversible reaction there. So it can go forward, can go reverse. So think of this like think of a reversible reaction like a car. So when pressing the pedal, it can either go forward or it can go back, depending on which gear it's in, that really doesn't relate here. But just think car, can go forward, can go back. So there's forward reactions, and then there's reverse reactions. So, and that's determined by actually the concentration of the reactants that's either added or removed. So if you increase the concentration of reactants, it's going to move away. So it doesn't matter actually which direction. If you increase the concentration of reactions, if it's on this side of the arrow, it's going to go that way. if you increase the concentration over here, reaction's going to go that way. So whatever you increase the concentration reactants, you're going to move away from it, and on vice versa that if you decrease the concentration reactants, the reaction's going to move towards it. So if it's on this side, it's going to move towards it. If you decrease the concentration of reactants on this side, you can move towards it here. So an analogy for this is kind of going out on a limb, but this should help you all get a better understanding. Definitely help me kind of click everything into gear there, that aha type moment. But if you eat too much food, food may actually go away from your mouth, so you're gonna barf. So if you increase the food, increase the fullness, food's gonna move away from your mouth. If you decrease your fullness, so decrease the concentration, if you haven't eaten while, food's gonna move towards it. So that's decrease in concentration reactions, move towards it, increase the concentration, increase fullness, move away from it there. So that's chemistry in a nutshell here. We're going to discuss a few more things in the next episodes, but 4 types of chemical reactions: synthesis, building up; decomposition, breaking down; exchange, combination of breaking down and building up; and then reversible reactions can go forward, can go reverse there, and it has those cool little, take a little selfie with